All right, Mr. Dibble here. Algebra 2, 1.2, simplifying algebraic expressions and equations. Let's not waste any time. I want to get through this. You want to get through this? Let's do it. So, 1.2 is it's mainly getting you back in the math game over the summer, which I'm still in, and we're going to be evaluating equations at given values. Now, all this stuff at the beginning here, by the way, you should not write down. All right, you should write down 1.2. Don't even worry about the rest of it. All right, 1.2 for now. All right, and then don't write down any of this and any of this. Don't write any of it. All right, I'll read it to you. And you listen. So we're going to be evaluating equations at given values. All right, that comes first. Then we're going to be simplifying by combining like terms and factoring. And then we'll be solving equations for specific variables. None of this is all that complicated, all right? And take it from me, the advanced math certified teacher, to tell you that this is not complicated. No, actually, it's actually pretty easy. Just follow along, you'll pay attention, and everything will be good. So, and if I ever stop talking, it's because I'm coughing to death. I just muted the microphone. So, like right about now. All right, so evaluate the expression for the given value or values. Now, you should write this down. Right? You should write that down. And you should not, you know what? I'm going to use red to tell you what not to write. Don't write that. And all right, so what you want to do is plug this into this. And please pause the video, whenever you need to write stuff down. I don't want you, all right? The whole point of me making these videos is so that you can listen to the problems when I'm doing them, like listen to me working them out, and have time to write down what you need to write down. So pause the video, write this down, and then play the video, and then we'll get to working it out. So here's the expression we've got. Whoa, no. All right, so here's the expression we've got. 2x squared minus 9. And we're trying to evaluate it at x equals negative 3. So all you got to do is plug negative 3 into x. And I'm just going to write it down where the x has transformed into this negative 3. You've still got, it used to be 2 times x squared. So 2 times our new x squared. And then minus 9. And now you just simplify. So again, you're going to do exponents first, like we did last section. The parentheses, there's nothing to do. Now you do exponents, so it's going to be 2 times negative 3 squared, negative 3 quantity squared. So negative 3 times negative 3. If you've got a calculator, you can do that, or please do this in your head. Negative 3 times negative 3, and that's definitely a 3. It's just like deformed or something. So that is a positive, because the negative times a negative is positive, and 3 times 3 is 9. So it's a positive 9. And then minus 9. So now you do multiplication, 2 times 9, that's 18, minus 9, which is 9. All right, congratulations. Now, that's all you do for those. You just plug in whatever value they say into your problem. You guys try this one. This is 8x squared minus 3x minus 15 evaluated at x equals negative 2. All right, so pause the video and you do it. Great job. You probably got the right answer. I'm super proud of you. Let's see. All right. So you've got negative 2. Plug that into x. Plug that into x. You've got 8 times negative 2 squared minus 3 times negative 2 minus, that's not a minus sign, minus 15. So once again, parentheses first. There's nothing to do in the parentheses because it's just negative 2. And I'm going to die. Hang on. I apologize. I'm not going to edit that out. I don't know how to edit videos. All right, so you've got 2 squared, negative 2 times itself, and that's what we're going to do first. So you've got 8, and then negative 2 times negative 2 is positive 4, minus, I'll just do this one step at a time. Then you've got you got a multiplication thing here. You got 8 times 4, and then you've got 3 times negative 2 here. Technically negative 3, but we'll just keep the 3 negative and not worry about it. So you've got 3 times negative 2. That is negative 6. and you've got 8 times 4, that is 32. So this is going to turn into 32. And this is going to turn into a negative 6, and you've got minus 15. So a negative and a negative make a, that's right, student, a positive. I'm sure you didn't say positive, but you should have. So treat this as like a Dora the Explorer episode or something. So you've got 32 plus 6 minus 15. And then you just work that left to right. 32 plus 6 is 38 minus 15. That's an 8, by the way. And that is like 23. Right? Yeah, that's right. All right. Very good. I'm sure you got 23. Everybody got the right answer. All right. So next, simplifying expressions and factoring. Factoring, everybody's favorite thing. All right. When everybody thinks about what they love about math, it's definitely factoring. So, and by the way, you should write this down. Simplifying expressions and factoring. And we got a couple of examples to do. In the first example, we've got 5x minus 12 minus 3x plus 4. All right. So all they want you to do here is combine like terms. Now, last section, we talked about how addition is commutative. And what I mean by that is that you can switch the order of things and the expression will stay the same. So I'm going to break this down for you real good, and hopefully that'll help you understand it. So we've got 5x plus a negative 12, right? So it's like minus 12, but that's like plus a negative 12. And like plus a negative 3x, and then plus 4. So if you look here, everything is adding together. Sure, these are negative values, but they're just adding to everything else, right? So this is really like 5x minus 12 minus 3x plus 4, exactly the same thing. And now we can take these and reorder them. I'll explain this a couple of different ways. If this way helps, then that's great. If it doesn't, maybe the next way will help, all right? So I'm going to reorder these where the x's are next to each other and the numbers are next to each other. So I'm going to take this negative 3x and switch it with the negative 12. So it's 5x minus 3x, or excuse me, like a plus a negative 3x. And then you're going to move the negative 12 over here. So minus 12 and then plus 4. And then now you treat this as like one problem. And remember, like negatives override positives. So that's really like 5x minus 3x. So that is 2x. And this is negative 12 plus 4, and that is negative 8. And that's your answer. Another way to think about this, excuse me if that blew out your ears, I'll try to keep it muted if I cough, but I'm trying to get through this. So another way to think about this is to think of it like this. Think that you've got, I'm going to use this cool green, so just look at all your x's and do them first. 5x and then minus 3x. Well, that's 2x. And then negative 12 and plus 4. And that's minus 8. Right? If you can see it that way, the biggest problem with students trying to do it that way is they forget the negative signs. They forget the negative signs in front of the terms. You have to remember those. Otherwise, it's pointless because you did it wrong. Right? So you try the next one. Those are w's, by the way. That's w squared plus 9 minus 4w squared plus 3w to the fourth minus 7w minus 11. Well, something I will say is that squareds can only combine with other squareds, right? W squared and negative 4w squareds can combine, but w squared and this plus 3w to the fourth, those cannot combine. Those are not what we call like terms. Like terms are things that can be combined, and they are, I'm trying to think of a way to explain this that's simple to understand, like the same like numbers can be combined together, and then the same letters with the same exponents can be combined together. So this is really 1w squared. Let's do the w squareds first. You've got one of them here, and you've got -4 of them here. So if you had 1 and then you took away 4, you have -3 of them, or 1 minus 4 is -3. So this is -3w squareds. All right, following along. Then that takes care of these. Then we move on to the 9. So these are numbers, just regular old numbers. And so you've got 9, that's not a regular old number, that's not a regular old number. Here is a regular old number, -11. So you've got 9 and -11. Those combine, a +9 and a -11, to give you -2. And then you've got w to the fourths and w to the firsts. There are no other w to the fourths, so you cannot combine them with anything. And there are no other w to the first powers, or just w's, so you cannot combine those with anything. So what you have is plus 3w to the fourth minus 7w. And that's it. You're done. All right? So let's move on. The greatest common factor. Write that down. And the definition. The largest number that goes into a set of numbers. And it's not, strictly speaking, a number. It can also be a variable. All right? Or a mix of numbers and variables. Right? And that's what we'll see, is a lot of times the greatest common factor is a mix. It's a number you've pulled out and a variable you pulled out, all right? And the variables can be raised to certain powers too. So let's look at this. Factor out the greatest common factor. So you've got 6x squared plus 4x cubed minus 2 plus 4x. Now, look through all of those terms. Excuse me. So looking through these terms, if you wanted to combine like terms, there's nothing to combine. You've got x squareds, can only combine with other x squareds. There are none. X cubes can only combine with other x cubes, which there aren't any, and so on, right? So there are no like terms to combine here. It's as simplified as it can get. But what we're trying to do is factor out the greatest common factor. Now, if you've forgotten what factoring refers to, that is talking about, like, look at each of the terms and see if they all have some factor in common. And what a factor is it's like a number or a variable that goes into what you have here. So the numbers that go into 6 are like 2 and 3. The numbers that go into 4 are 2 and 2. 2 is like 2, that's just 2. And technically, if you want to talk about it, then it's like 1, but we don't really care about 1 when it comes to factoring. And then 4 is like 2 and 2. So if you're looking at each of these factors, 2, 3, 2, 2, 2, 2, and 2, is there a factor that goes into, like, is there a common number among each of these factors? And there is. It's 2. There's a 2 there, a 2 there, a 2 there, and a 2 there. And what this means is that factoring is like a lot like division. Like, if you can afford to divide out 2 from each one of these numbers, then it is a common factor. It would be the greatest common factor if it was the largest number that could be divided out of these terms here. So, is there any other number that goes into 6, 4, 2, and 4 that is bigger than 2? Think about that. Is there any other number that can go into 6, 4, 2, and 4 that is bigger than 2? And the answer is no, there can't be, because a number bigger than 2 cannot go into 2, right? So 2's got to be the greatest number. So factoring that out, you'd factor a 2 out, and this is what it means to factor it out. It's like division. Think of this like division. What is 6 divided by 2? Well, 6 divided by 2 is 3, and then the x squared drops down. Then you've got, what is 4 divided by 2? Well, that's 2. And then the x cubed drops down. It stayed x cubed. Then here, the negative will stay, or what is negative 2 divided by 2? That is negative 1. So that drops down. And then a positive 4x divided by a 2. That's like positive 4 divided by 2, and then drop down the x. Positive 4 divided by 2 is 2. And so it drops down in the x, and it goes into 2. Now here's how you can know you did this right. All right, this is important. How you know you did it right. If you could redistribute the 2 back in, you guys remember distributing? You'd get 6x squared. Hey, look, 6x squared. Then you'd have 4x cubed. That's 4x cubed. Now 2 and negative 1 make negative 2 when you multiply. And 2 times 2x is 4x. All right, that's how you know you did it right. This is like factoring. Right? This is what factoring is. It's like the step. It's like reverse distributing, right? It's creating something in which you could distribute back in. Now, something we want to look for is if there was a common variable we could have taken out, then we would want to have done that as well. But there's not, because since the 2 doesn't have an x associated with it, all the others have some amount of x's associated with them, but only the 2 has got just a number. So you can't pull out x's because the 2 doesn't have any to pull out. And we'll see more of this later. All right, please raise your hand if you have questions over this. Actually, maybe wait until the next example, and then if you have questions over that one, definitely raise your hand. All right, I'm here to help. Who knows what I'm doing at my desk right now, but definitely ask questions if you have help, or if you need help. Yeah, just don't you worry about that. All right, next is solving for specific variables. What we want to do here is, this is like something fairly different. We want to solve this equation for w. All right, so we've got a equals L times W. And this is like the area of a rectangle, right? You got a rectangle, that is a terrible rectangle. You have a rectangle, and it's got a length and a width. The area of said rectangle is the length times the width, right? You guys remember that? So that's an actual formula, and we're going to solve it for W. So if you guys remember like one-step equations, we want to solve for W, and you're thinking, well, how do I get that to be by itself? Well, I always like to think of a similar equation where it gets to the root of what you need to do, but it does it in a way that you understand it. So it's something equals something times what we want by itself. All right, that's the idea. Something equals something times what you want to solve for. So let's think of that as a different problem. If this helps you, then that's great. And if it doesn't, then I'll come to another way. So think of this as like 4, that's something equals something times what we want. So 4 equals 2 times that's something we want. Or like 2W. Do you guys remember how to solve like one-step equations like this? You should say, right, this is like the Dora the Explorer time where you say it to yourself. That's right, you divide by 2. You divide by this thing that's next to it. You divide by 2 on both sides. You guys remember solving one-step equations? It's the same thing over here. You just divide by L. Divide by L. And you're going to get that the A over L equals W. And that's it. You're done. All right. Let's solve this one for H. Area equals 1/2 base times height. Well, that is the area of a triangle, right? So we're going to solve this for H. Now, this is a little trickier, but it's still like something equals three things being multiplied. Now up here, we just divided by the L. Well, what we could do here is divide by the 1/2 B, since we're solving for H, and that will cancel. Divide by 1/2 B. And then you're going to get A over 1/2 B. And that's a really sloppy way to see it. Now, if you were actually doing computations on a calculator, this would probably tell you the right answer because your calculator would know if you entered it properly. But we're going to do this a slightly different way, right? We're going to look at it like this. So you've got your A equals 1/2 base times height. We're going to get rid of the 1/2 first. Now, to get rid of a half, you could think of it like we did as dividing by 1/2, because anything over itself cancels, like 1/2 over half cancels, right? Makes 1. But dividing by fractions is the same as multiplying by that fraction's reciprocal. And if you remember what reciprocals are, they are the fraction upside down or flipped. So instead of 1 over 2, it's 2 over 1. So instead of dividing by 1 over 2, we're going to multiply by 2 over 1. And if you have forgotten how to multiply fractions, join the club with probably the rest of your entire school, which pains me greatly. But to multiply fractions, you multiply straight across. So you got 1 times 2, which is 2, and 2 times 1, which is 2. And that's why it creates this canceling effect. You again have 2 over 2, which is 1, and that cancels. So this is why this works. And what you do to one side, you have to do to the other. So we're multiplying this by 2 as well. And so you'd have 2A equals BH. And now do what we did here and divide by B. Divide by B. This is much cleaner. You've got 2A over B equals H. Ta-da. Very good. Here's your homework. You guys have a lot of problems, but they take not very long to do. You'll be fine. And this was only a 22-minute lesson. Right? If you have any questions, please feel free to raise your hand. There should be a video over this homework assignment along with all the other homework assignments on my YouTube channel. Right? Have at it.